In this lesson, you'll learn how to model multiplication and division. And we're going to look at three strategies: how to model it using area, a set of objects, and a number line. First, area. Let's pretend we want to fill our kitchen, or we want to fill my kitchen with some objects. We want to fill it with a refrigerator, a dishwasher, stove, some counter space, cabinets, and let's throw in a rug. Alright, if you want to figure out whether all of this can fit in your kitchen, you can use multiplication and division in the area, using the area strategy. So first I have to figure out how big is my kitchen. Well, I've already drawn it out. I have 10 feet. It's 10 feet going this way, 9 feet this way. So there are 10 rows of 9 feet. That would make it 10 times 9 equals 90. And if you look at the multiplication formula, the number of rows, there were 10 rows, times the number in each row, there are 9 in each row, is equal to the total number. So I have 90 square feet in my kitchen. And if I wanted to look at the division, I take the total number. If I want to know the total number, I take the total number 90 divided by the number of rows. I had 10 rows, which equals the number in each row. So 90 divided by 10 is equal to 9. So that would be the area, the multiplication and the division problems that are represented with this picture. Now, if we want to put the refrigerator is 2 rows times 2 in each row, which is equal to 4. The division model is 4 total divided by 2 rows. Remember, rows go this way, columns go up and down. So rows are horizontal, columns are vertical. 4 divided by 2 is equal to 2. That's what's modeled here. And the dishwasher and the stove just happen to be the same. So that saves us a couple steps. For the counters, I have 3 times 5 equals 15. Let's see if that's correct. We have 1, 2, 3 rows times 1, 2, 3, 4, 5 in each row, which is equal to 15. It's going to take up 15 square feet. And then if I wanted to represent it in the division model, I would say there are 15 total squares divided by 3 rows is equal to 5 in each row. For my cabinets, there are 2 rows, 1, 2, with 4 in each row, 1, 2, 3, 4, which is equal to 8. Or there are 8 total divided by 2 rows, which is equal to 4 inside each row. For this other set of cabinets, there's 1 long row, so that would be 1 times 8. There are 8 in each. 1 times 8 is 8. Or the division model is 8 divided by 1 is equal to 8. And then if we wanted to throw a rug in the kitchen as well, we can say that it might be about 1 row times 3 little square feet. 1 times 3 is 3, or 3 divided by 1 is equal to 3. So I've used this kitchen model just to show us a real life example, but each of these pictures, we're trying to figure out which multiplication and division problem is represented by those pictures. And then if we go ahead, add all of these up, all of these squares, we would have 46 square feet is how much room we need. And we have over here, remember, 90 square feet total. So it's almost half the kitchen. That should all fit nicely and leave plenty of space. For the set model of multiplication and division, I call this the circles and stars method, and we'll play a game in class called Circles and Stars. So I'm going to start out with that. If I were to roll a dice or roll 2 dice and get 8. And I have 8, I'm going to draw 8 circles. 1, 2, 3, 4, 5, 6, 7, 8 circles. Then I'm going to roll the dice again and I get snake eyes. I get 2. So I have 8 with 2 in each circle, 8 times 2. And if you were to add up every single star, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We know that 8 times 2 is 16. So it says with the set, the number of groups, you have to write down first. Then the number in each group, there are 2, is equal to the total number. If we were to look at the division problem, or the division representation, you would take the total number of stars, 16, divided by how many groups, there are 8, and you're going to have that equal to the number inside each group, and in each circle there are 2. So this would be the division problem represented with this picture. Well, what about if we had a real life example? I have 4 boxes of shoes. I have a pair of high heels, couple flip-flops, and a pair of boots. So we have 4 groups times 2 in each group is equal to 8 total, or 8 total pieces or 8 total shoes divided by 4 groups is equal to 2 inside of each group. Another example, if we were to go buy some dog bones, we would say that we need, or we have bought 5 buckets or 5 boxes of bones times, they said that there are 15 in each bucket. 5 times 15 we know is equal to 75, or 75 total bones divided by 5 groups is equal to 15 inside of each group. The last model we're going to look at is the number line model. When we're using a number line, you want to be sure to make sure each little teeny line is perfectly spaced out. And you want to make sure that you haven't skipped any numbers because it would throw off your data. It would throw off your number line. So let's look at the first example. This one is showing us 3 hops. So we have 3 hops here, and in each hop they're skip counting by 12. So 12, 24, 36. 3 hops of 12 is equal to 36, and you can see they land on 36 there. Or 36 is where they landed, divided by 12 inside of each hop is equal to 3 hops. So let's look at the formula for the second one. We know that the number of hops is going to come first. So we have 8 hops here times the number inside of each hop, or what you're skip counting by. So you have 4, 8, 12, 16, 20, 24, 28, 32. You're skip counting by 4s. So 8 times 4 is equal to the total, and we finally land on 32. So 8 times 4 is 32. Or the division model, you take the total number you land on, 32, divided by each time, or what each hop is skip counting by, divided by 4 is equal to 8, or is equal to the number of hops, and there were 8 hops. For the last example, we have 7 hops times, we're skip counting by 3 in each hop, so 7 times 3 is, and we land on 21. And for the division model, they landed on 21, divided by, and for each one they're skip counting by 3, which is equal to 7 hops. I want you to apply your knowledge now. For number 1, this would be similar to the area model, or when we were putting things into our kitchen, we were using the area or the inside. So we can see that there are 1, 2, 3 rows. So we want to write that there are 3 rows of 1, 2, 3, 4. 4 is equal to total, 4, 8, 12, there are 12 stars there total. So if we want to know which multiplication problem is represented by this picture, that would be it. Now for division, we know that there are 12 total, divided by 1, 2, 3 rows is equal to 4 in each row. For the second example, this example is using a set model. We have 6 groups times 1, 2, 3 in each group, so there are 18 stars total. If we want to look at the division model, we know that there are 18 total, divided by 1, 2, 3, 4, 5, 6 groups is equal to 3 inside of each group. For the number line model, we see here that they stopped at 5, 10, 15. There are 1, 2, 3 hops. So we are going to say that there are 3 hops of, let's see, they're skip counting by 5. 3 hops of 5, which is equal to 15. Or the division problem, 15 divided by, and each time they're hopping by 5s, 15 divided by 5 is equal to 3 hops. Number 4, this would be the area model again. We have 1, 2, 3, 4 rows of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We know 4 times 11 is 44. Or the division model, 44 divided by 1, 2, 3, 4 rows is equal to 11 inside of each row. And the last example, going back to our base 10 blocks, we have 2 10 rods, so we have 20, and then 1, 2, 3, 4, 5, 6, 26. Let's make sure that's over here as well. 1, 2, 20, 10, 20, 21, 22, 23, 24, 25, 26. So we have 2 sets of 26. So we're going to do 26 times 2, or 2 groups of 26, and we have a 2-digit number, we write it on top. So we have 6 times 2 is 12, regroup your 1, 2 times 2 is 4, plus 1 is 5. 26 times 2 is 52. Or the division model would be 52 divided by 2 groups is equal to 26 inside of each group.